In order to use the Euler's method, you need to create a table consisting of 5 elements, which are the values of x and y, dy over dx, delta x, and delta y. Now, dy over dx is equal to the slope, which is m. Delta x is equal to the difference between the x values we use, which is also the amount of step that we take. So in this case it is 3.2 minus 3. So we should do this in one step. So our delta x will be 0.2. Our x and y values are given, 3 and negative 2, and then we can find dy over dx by the given equation, which gives us 5 over 4. Negative 4. So negative 5 over 4 is, in other terms, negative 1 over 25. So in order to find delta y, as in always, delta y is equal to the slope times delta x. So in this case, it's equal to negative 5 over 4 times 1 over 5, which is equal to 1 over 4, which is equal to negative 1 over 4, which is equal to negative 0.25. So now, our initial y value is negative 2 if we look at the table, and then our change in y values is negative 0.25. So if we add these two together, we get a negative 2.25, which is in D. Again, we draw our table with the 5 elements, the values of x and y, dy over dx, delta x, and delta y. So in this case, our x and y values are given as when x is 1, y is 0. So if we put it into the equation, the derivative of fx is 1 over x, we get dy over dx to be 1. And then it says this time we need to do this in 2 steps. We need to get from 1 to 1.5 in 2 steps. So we need each step to be 0.25. So our delta x is 0.25 and our delta y is the slope times delta x, which equals to again 0.25. So now our initial y was 0 and then delta y was 0.25. So we get 0.25. And then for y in the next step, and then we get 1.25 in the next step for x. Then we calculate dy over dx again and find that it's 1 over 1.25. And then the delta x is again, we're using equal steps. So again, it's 0.25. So we multiply it with the slope and we get a 0.20 for the change in y. Again, we add the initial y value with the change in y values, and we get a 0.25 plus 0.20, we get a 0.45, and now we write it as it's shown. Again, we will have our values of x and y, and then dy over dx, delta x, and delta y, which is equal to slope times delta x. So our x and y values are as given when x is 0, y is 2. So our dy over dx would be xy over 2, which is equal to 0 in this case. Then our delta x is, we're trying to get from 0 to 2 with step sizes of 1. So we are already giving the size of our step, so delta x will always be 1. And then the slope times delta x is 0, which is delta y. Now our new x is 1, our y is still 2 because we added nothing, and then our new slope is calculated as to be 1, and then our delta x is again 1, and our delta y is m times delta x, which is equal to 1 this time. So our new x is 2, but also our new y is 2 plus 1, which is 3. So when x is 2, we get a y value of 3, which means that f2 is approximately 3. Again, we will have our values of x and y, dy over dx, which is m, and delta x and delta y. Now our initial condition is when x is 3, y is negative 2 as the point is given. Our delta x is also given negative 0.1. So our m is, if we calculate it, turns out to be 4.5. And our delta y is m times delta x, which is negative 0.45. Now our x is, if we add x and delta x together, is now 2.9. Our y is, if we add y and delta y together, is negative 2.45. Our m, if we calculate it from the TI, is negative 3.43. And then our delta y is equal to m times delta x. So it's negative 0.343265. And of course you can still write more decimals, but this is for now, I think, is enough. And then we have 2.8 for x. And then we're looking for the value of y when x is 2.8. So y value right now will be our value, but we need to be careful about the decimals. We need to write 9 decimals from what we see on TI.